So today we're going to talk about trapezoids. We're going to do kites tomorrow. I switched the order. It doesn't matter if you do kites or trapezoids first. So we're going to do trapezoids today. It's a really easy concept. My first question would be, what's the difference between a trapezoid and what we have been talking about, which are parallelograms? Why is a parallelogram and a trapezoid different? Not equal sides. It does have to do with their sides, though. Okay, parallelograms have two pairs of parallel sides. The tops and the bottoms and the left and the right are parallel. What about trapezoids? They only have one pair, and it's the bases are parallel. So this is a base. And this is a base. And your bases are the ones that are parallel. Those little arrows mean that they are parallel. That doesn't look like an arrow. Let me fix it. Okay? So that takes care of that characteristic. And then the other characteristic of trapezoids share the same as the parallelogram. They're the same. Same side interior angles are supplementary. Okay, so that means that this angle here, if it were 100 degrees, what would this angle have to be? Okay. 80. Because 180 added together would be 180. Supplementary. Okay, so if they're both on the left side, they're same side interior angles, they add to 180. Okay, same thing over here. If this one was 120, what would this angle have to be? 60. Okay. So that's, in a nutshell, what a trapezoid is. Now, there are special types of trapezoids called isosceles trapezoids. You've probably heard isosceles with what? Triangles. Isosceles just means what when it involves triangles? Two sides are equal. So same thing with a trapezoid. Isosceles trapezoids mean that the legs, which are these guys, the legs are congruent. Different than this original trapezoid when this leg was not the same as that leg. Okay. So we still have the top and the bottom parallel, the bases. The base angles are congruent. So that means if this is a base and this is a base, the base angles would be the two top angles and also the two bottom angles. Those would be congruent. So let's say this angle up here was 50. What else do we know? This other base angle would also be 50. And what would this angle have to be? Why 130? Yeah, because these two are supplementary. They add together equal 180. So this one would also have to be 130. The last thing, so we've done these two. The last thing isosceles triangles, oh my gosh, isosceles trapezoids have are congruent diagonals. So this diagonal here is the same distance or length as this diagonal here. So if this diagonal is 25 inches, then what would this diagonal be? 25. Same with the part. So if this part right here was 20, then this part right here would also be 20. Then this part would be 5. This part would also be 5. Okay? So all parts of your diagonals would be congruent in an isosceles trapezoid. Okay. So now we're actually going to look at some problems. The first one involves the angles of an isosceles triangle, but check out this trapezoid. It's laying on its side, isn't it? Because this is a base and this is a base, because those are the parallel sides. So we're given that angle D is 117 degrees, and we're looking for the measure of angle A. So we're looking for that angle. How are we going to find it? Yeah, because what are A and D? Supplementary. They're supplementary angles, so you know they have to add to 180, so what would you do to find A? Right. 180 minus 117, and what do we got? 63. Very good. Trapezoids are very easy. Okay. Number 2. What do we got here? What are those? Diagonals. And what do we know about diagonals? Especially because these are isosceles, because the two legs are congruent. So diagonals are also congruent in every part. So FB is congruent to JB, KB is congruent to BM. Okay? So MB, where's MB? That's this. I'll highlight this right here in yellow. This little segment right here is 21.9. So according to our rules, what else would be 21.9? KB. Good. Okay. Then it also gives us that KJ, which is the entire diagonal, all the way is 32.7. And then what does it want us to find? It wants us to find this little piece right here, JB. But we know the whole thing, and we know this section here. So how are we going to find it? Yeah, just subtract. 32.7 minus 21.9.
I'm going to explain myself to you. It's got nothing to do with me.
Uh-oh. Okay, so 32.7 minus 21.9, what'd y'all get? What? 10.8. Sweet. Okay, we're going to move on to example 3. Moving right along. Okay, the measure of angle SPQ. Which one is that? Which one letter is really SPQ? P. So that guy right there is a squared plus 27. And the measure of angle PSR, which is really what angle? S, is 2a squared minus 54. Okay? Find the value of A. And we know that this is what kind of trapezoid? Isosceles. So what do we know about these two angles if it's an isosceles trapezoid? Why are they equal to each other and not adding to 180?
Because we're not something.
Yeah, the sides are equal. And also remember, this is the base and that's the base. It's sitting on its side right now. Okay? So really, if I turned it right side up, like if I turned it to make it look like this, which it would look a lot better than that, then remember these two are the ones we've marked. So those are the base angles of the top, and these would be the base angles of the bottom. So the top angles would be equal to each other. So what equation would you set up? Okay, so we're going to set these equal to each other. A squared plus 27 equals 2a squared minus 54. Okay, and we want to get a squared by itself so we can get a by itself. Okay, so what's my first step in solving for a squared? Subtract what? The a squared from both sides. Good. Baby to the mama. So 27 is equal to, 2a squared minus a squared is just a squared minus 54. Next step. Yeah, we want to get the a squared by itself, so we want to get rid of the minus 54 by adding 54 to both sides. Yes, 81 equals a squared. Okay, but we don't want a squared, we want a. Yes, the opposite of squaring is square rooting. So the square root of 81 is 9. That's the only one where you're going to have to do the square root. Any questions on example 3? Yeah, trapezoids are really basic. Okay, what do we have going on here? Diagonals. And if it's an isosceles, we know the diagonals are equal. Okay, so AC is all the way this way. Is 12x minus 11, and then BD, this guy, is 9x minus 2. So if we know both diagonals, what can we do to set up our equation? Yeah. So really, you're either setting something equal to each other or you're adding them together to equal 180. Yeah. Okay. How will we solve for x here? Okay, baby to the mama, subtract the 9x. Good. Okay, we got to get rid of everything by our x, so we're going to add 11. Good, yes, negative 2 plus 11 is not 13, okay? This is a negative. So 3x equals 9. Yes, x equals 3. Is that all it's asking for? Find the value of x. So yeah, we found x, and we are done. Any questions on example 4? Okay, last one, example 5. Given that EFGH is an isosceles trapezoid, so notice the congruent markings on the legs, and the measure of angle E is twice the measure of angle F. So E is twice what F is. So how am I going to mark that? Which ones are X? F. Because E is twice what F is. So E is 2x. Very good. Okay, because it's an isosceles trapezoid, H is also 2x because they're base angles. And G is x. Good. That'll help us when we have to answer this part right here. But first off, we have to find x. We can't do 2x equals 2x. That's not going to help us. What? Right. These two are what kind of angles? Supplementary. So we add them together to equal 180. What's 2x plus x? 3x equals 180. Then divide by 3. X is 60. But are we done? No, because what are we looking for? We're trying to find the measure of angle measure of angle H, which we've already labeled as 2x. So it's important to label your trapezoids. Yeah, 60 times 2 or 2 times 60 is 120. So the measure of angle H is 120. So this one's also 120. This one is 60, and this one is also 60. So how many degrees are in all of the angles of a trapezoid? 360, because what kind of shape is it, really? No, it's not a parallelogram. Okay, what is the overall shape? Quadrilateral. 4 sides. Quadrilateral. All quadrilaterals have 4 sides, so they have how many degrees? 360. Because remember our formula? Well, that's too bad because it's written right up there. N stands for the number of sides, so 4 minus 2 is 2, and then times 180 is 360. So anything with 4 sides will have 360 degrees inside of it. Okay, that's just a reminder for you. Okay, go ahead and turn on the back. The back is a review. We've already done mid-segment theorem. Already. Here is the mid-segment. What does it look like a mid-segment is? Describe it to me. It's in the middle. What else does it do? Cuts it in half, so the top leg cut in half, so it bisects each leg. What else? Very good. It's parallel to the bases. So this is parallel to the mid-segment, is parallel to the other base. Is it just somewhere in between the bases? It's exactly in the middle. So what do we also call the middle in math? Sort of, but it's not a point. Okay, let's say we had the numbers 10 and 4. What's in the middle? 10 and 4. 7. So 7 is the what? It's something we use all the time because you're in school. And right now you're trying to get it to a certain point so that you get credit. Average. Good. It's your average. So the mid-segment is the average of the two bases. I was trying to get average. Okay? All right, trapezoid mid-segment theorem. The mid-segment of a trapezoid is what in comparison to each base? Parallel. Good. And how do you find the average of two numbers? Okay, so how do you find the average of any numbers? Add them together. So we have to find the, what's another word for adding them all together? Finding the sum. So we have to find the sum of the lengths of the bases. So add the top and the bottom, and then take half of it, right? Add them together, divide by 2. So if I wanted to add, let's see, 10 and 4, our earlier example, 10 plus 4 is 14, divided by 2 is 7. That's the average. Same thing with mid-segment. So like if you made 100 on a test and 50 on a test. 100 plus 50? 100 plus 50 is 150, divided by 2 is 75. Okay, so we're finding the average, the mid-segment of our bases. So what are our two bases here? 13.5 and 8. So really, this is kind of what the formula looks like. The two bases, base 1 plus base 2 divided by 2 will give us our mid-segment. Okay? It doesn't matter which one is your base 1 and your base 2. So which one do you want it to be your base 1? 8. Awesome. What's your other base? 13.5. Would it matter if I did 13.5 plus 8? No. And then we divide by 2. So the first thing you're going to do is clear off the top of your fraction. We're going to add first. 8 plus 13.5 is? Okay. And then divide by 2. Good. Yeah, that's simple calculator work, or you could do division. So EF is equal to, what is it, 10.75? Very good. So mid-segment is pretty easy. Okay, what's the difference between 7 and 6? What is 7 asking for? Right, but what does X represent here? One of the bases. So in this case, we know base 1, but we don't know base 2. So that's going to change how this looks. So base 1 is 16 plus X, not 24, because 24 is not your other base. Divided by 2. And remember, this equals our mid-segment. So we know what the mid-segment is. It equals 24. Okay? So how are we going to get that X right there by itself? Yeah, it's dividing by 2. So to get rid of that, we're going to multiply both sides by 2. So 16, oops. Alright, 16 plus X is what's left on the left side is equal, and what is 24 times 2? 48. Okay, and one more step and we know what X is. Subtract 16. Good. So X is 32. So doesn't it make sense that this, the X, is the bigger of the 3 numbers? Yeah, why does that make sense? It's the longest side. The longest base will be the biggest number. The mid-segment will come in between, obviously, the 2 bases, and the 16 is the smallest. Very good. Okay, last problem. Put that off your screen. Okay, so again, we're looking for LM, which is our mid-segment. We got to label some things here. So HI is X plus 1. LM, our mid-segment, is 2X minus 4. And KJ, the base, is 2X plus 1. So you're going to follow your formula. B1 plus B2 divided by 2 equals your mid-segment. Okay, so what is B1? X plus 1. Plus, what's your other base? 2X plus 1. Divided by 2 equals your mid-segment, 2X minus 4. Okay, this looks a lot longer than the other ones because you got a bunch of variables. But it's the same process. It's the same process that we used in this problem here. What was our first step in solving over here? Multiply by 2 to both sides. So that's what we're going to do here. We're going to get rid of this division by 2. So we're going to multiply 2 to both sides. But here's the deal. When you're multiplying by 2 to the right, you have to multiply it times everything. So what is that process called? Distributing or distribution. Very good. So what is 2 times 2x? 4x minus 8. Very good. And I want to clean this up a bit, because what can I do up here? Combine like terms. Yes, add the variables and the numbers. So we have x and 2x plus 1 and 1 is 2. Okay, that's my ugly line down the center. So now this is a nice easy baby to mama problem. subtract the baby, which is 3x. So 2 equals x minus 8. Yeah, do I plus 2 or do I move the 8? Yeah, I want the x by itself, so I want to add the 8. Why do I add the 8 and not minus the 8? Because it's already subtracting. I do the opposite. Good. Am I done? Yeah, because what is it asking for? LM, which is our mid segment, which is 2x minus 4. So all I do is plug it in. 2 times 10 minus 4 is 16. Very good. LM is 16. Are there any questions about trapezoids?